So if you're feeling confident about your ability to find the derivative formula for one of these quadratic functions, we've done a couple of these already, you can skip to the second half of this video where we go through this for a cubic function. But otherwise, we'll embark on this one. So we've got our formula for the derivative using the limit as h approaches 0, the difference quotient. So I'm going to now get specific to our function here. So the limit as h approaches 0 of, now I've got to plug x plus h into this function here. So we're going to have negative x plus h squared plus 6 times x plus h, and then plus 7. So there's our f of x plus h, and then minus, so we're just going to subtract the original function, negative x squared plus 6x plus 7. And then the denominator is our old standard, x plus h minus x. So we've got some work to do up in that numerator. So let's set out on that. So for starters, we've got to FOIL out that x plus h squared and then hit it with a negative. Well, we have FOILed x plus h a couple times, so hopefully at this point we know it's going to be x squared, which is going to become negative, 2xh, which is going to become negative, and h squared, which is also going to become negative, all because of that negative sign there. Then we're distributing the 6, so we get plus 6x plus 6h, and then finally plus 7. And now into the set of parentheses here at the back end, we're going to distribute that negative, so we're going to get plus x squared minus 6x minus 7. And then in the denominator, x plus h minus x cleans up as always into just h. No setting h equal to 0 yet. We've got to gather our like terms in the numerator. So negative x squared, positive x squared, gone. 6x and negative 6x, also gone. 7 and negative 7 cancel each other out. And so as we have said before, everything in the numerator at this point has to have an h in it. We've got negative 2xh, we've got minus h squared, we've got plus 6h all over h. And so now we can go ahead and remove the discontinuity. We can divide everything by h. So we've got the limit as h approaches 0 of, so the h cancels out everywhere. Oops, don't need this line here. And we've got negative 2x minus h plus 6. And so we are now set to go ahead and apply our limit to set h equal to 0. And so we can see that we end up with negative 2x plus 6 as our formula for the first derivative of this function. So for our last example, we're going to torture ourselves by applying this process to a cubic function. So we've got our difference quotient with the limit as h approaches 0 applied to it. So let's see how this goes. So we've got our first derivative is equal to the limit as h approaches 0 of, now I need to take x plus h and plug that into my function everywhere. So we're going to have x plus h cubed plus 2 times x plus h squared minus, make sure it's in parentheses, x plus h plus 3. And then we still have to subtract our f of x, which is just the original function. So x cubed plus 2, oops, try that again, plus 2x squared minus x plus 3. So on the bottom, x plus h minus x as always. So in the numerator, we got a pretty significant amount of foiling and distributing to do. So let's get going on that. Important that we be as accurate as we can here. So we've got a lot of space here. So x plus h cubed, we can either take our x plus h squared answer and multiply by x plus h, or we could use Pascal's triangle and the binomial expansion that we studied previously. So that's the approach I'm going to take. So I know that my first term is going to be x cubed plus 3 times x squared h plus 3 times xh squared, and then plus h cubed. So that's my expansion of x plus h cubed. Now I've got to work on this piece. So we've done x plus h squared, that quantity squared, a number of times. Now I just have to double everything. So we're going to have plus 2x squared plus 2 times 2xh is 4xh, and then plus h squared times 2 is plus 2h squared. So we've got that much. Now I need to distribute the negative here. So we get a minus x and a minus h, and then plus 3 to close things out. And then of course we have to distribute the negative here. So we're going to have a minus x cubed, a minus 2x squared, a plus x, and a minus 3 to close things out. So that has our numerator, and now we just have h in the denominator. So our gathering of like terms can get started, when we just have to be careful that we don't lose track of anything when we're all done. But I've got an x cubed and a negative x cubed. I next see a positive 2x squared and a negative 2x squared. I can see I have a negative x and a positive x. And then finally I have a plus 3 and a minus 3. So out of all of that, when we're all said and done in that numerator, we're going to apply the limit as h approaches 0 to 3x squared h plus 3xh squared plus h cubed plus 4xh plus 2h squared, and then don't overlook this guy, minus h. And then that's all over h. And so at this point, we're ready to go ahead and remove that discontinuity, go ahead and divide everything by h. So that h goes, this h goes, this just becomes h instead of h squared, this becomes h squared instead of h cubed, this h disappears, this just becomes h, and then this lastly becomes minus 1. So now we're going to apply our limit as h approaches 0 to 3x squared plus 3xh plus h squared plus 4x plus 2h minus 1. And so if we set h equal to 0 now, we've got 3x squared left. This is turned into a 0. This has turned into a 0, plus 4x. This turns into a 0, and then finally minus 1. So here's the formula that we can plug into to find the slope of a line tangent to this function at any value of x. So if you can get through a cubic function like this, you can get through just about anything that I'm going to throw at you. So congratulations.